So today we're going to be talking about area of 2D shapes and volume of 3D shapes. So this is going to be a two-part series. Today we're going to go over squares and cubes, rectangles and rectangular prisms, circles and spheres. So just as a general rule of thumb, area equals length times width. And so that will vary depending on the shape, but that's kind of like the basis. That's where we start with when we want to find area. And that will work for two-dimensional shapes. When we're talking about volume, we have 3 dimensions now. So I wrote here big B times h. H is going to be our height, and B is going to be the area of the base. So really the base is going to be a two-dimensional shape. So you can also say this is length times width times height. But I like writing the variable capital B because it shows us that the base, the area of the base will vary. So first thing we're going to go over is squares. So square has 4 equal side lengths and 4 right angles. So I'll call this side 4 centimeters. And I want to know the area of this shape. Well, we just said area equals length times width. And I know all 4 of these sides are equal to 4 centimeters. So I can say area equals 4 times 4, 4 centimeters times 4 centimeters, which is equal to 16 centimeters squared. Don't forget to multiply your units. It's 4 centimeters times 4 centimeters, not just 4 times 4. And this square will also tell us that we're talking about area. Another way that I like to think about this is I had 4 units going this way, so 1, 2, 3, and then 4. And I had 4, 1, 2, 3, 4. So really it's like 4 columns, and in each column there are 4 units. So like that's kind of why area equals length times width. So if I wanted to write a formula for the area of a square, well, it is length times width, but length is equal to width for a square. It's 4 all the way around. So really we can just say it's side length squared. Because even though either one would work, this is a more concise way of saying it. So if we wanted to find the area of a square, we can just take the side length of the square and multiply it by itself. And we would get the same answer as we did here. So next we're going to talk about cubes. For cubes, I like to imagine a cardboard box because my drawing is not going to be fantastic, so just imagine that. So let's say this is my cube. I know it looks rough. So cube, it has 6 faces, and they're all identical. So by faces, I mean there's like a square in the front, square in the back, on the top, the bottom, left and right. And all of them are equal squares, or equal side lengths. So if I said this was 4 centimeters, this is 4, this is 4, this is 4, this will be 4, this will be 4, etc. So if I wanted to find the volume of this shape, I want to know how much can fill this cube. Well, now we're working with 3 dimensions. It's not just length times width. But we can refer back to our formula. We can say volume is equal to big B times height. And we just said that the area of a square is equal to side length squared. And in this case, our base is a square. Any of these squares will be the exact same. So that's going to be side length squared. But we need our height, and like we just said, all of the side lengths are equal to each other. So we know it's going to be 4, or it's going to be equal to this s right here. So we can say the volume is side length squared times side length, which we can write as side length cubed. So the volume of a cube is the side length cubed. So we would do 4 times 4, for the area, but if they told us it was a cube, we would do 4 times 4 times 4. So in this case, it would be 4 centimeters times 4 centimeters times 4 centimeters. I don't know why that didn't write out. There we go. So that'll equal 64 centimeters cubed. Don't forget your cube there, because we're multiplying the units. So that's it for cubes. Now we're going to talk about rectangles. One important thing to note is that a square is a rectangle, but a rectangle is not a square. So what that means is that a square is kind of like a special rectangle, in that all the side lengths are equal and it has 2 pairs of equal sides. So I'll draw this out for you. So this is my rectangle. But a rectangle isn't a square because these side lengths aren't all going to be equal. And then of course we have right angles over here. So that's just something to know whenever you need it. So if I wanted to find the area of this shape, let's say this is 3 centimeters, this is 5 centimeters. We'll refer to our formula and say area is length times width. So we can say it's 3 centimeters times 5 centimeters. So that's going to equal 15 centimeters squared. But keep in mind that it's not side length squared, because these two aren't going to be equal to each other. Length does not equal width in this case. So it's just going to be area equals length times width. The formula didn't change at all. So rectangular prism, it's basically, if you don't know what that is, you can kind of tell in the name it says rectangular. So that tells us our base. Our base is a rectangle, but it's a prism because we have depth now. So you can think of like a tissue box, for example. So I want to know the area of this shape. So let's again say this is, or not the area, excuse me, the volume. So let's say this is 3 centimeters. And we'll say this is 5 centimeters. And this is 4 centimeters. So one thing to note about rectangular prisms is that all 3 dimensions can be different values. So length does not equal width in a rectangle, and height will not necessarily equal width or length. I suppose it could, but usually it's not going to. Alright, so I want to find volume. So we just said that the area of the base is length times width. So we do 3 centimeters times 5 centimeters. But now we have the height. So let's remember volume is the area of the base times height. So our height, or depth in this case, they tell us is 4. They might tell you on like a word problem. You'll usually be given all 3 of these. So it's going to be 5 times 3 times 4. I'll go ahead and tell you that's 60. And then we multiply our units, which is centimeters cubed. So in this case, our volume is just going to be, for a rectangular prism, length times width times height. So now we're going to move on to circles and spheres, which this is a little different. We can't exactly go directly to our area and volume formulas that I talked about, but I'll go ahead and walk you through it, how we can find it anyway. So let's start with this circle. So like I said, we can't do our normal formula because we don't have sides. It's just smooth all the way around. But we do have the center of the circle. And from the center to the outside is something known as the radius. The radius. And then so in this case, we'll say that it's 5 centimeters from the center to the outer rim. But I want to know the area of this circle. Well, the formula that you'll see is pi times r squared. R is going to be our radius, so in this case we would do 5 squared times pi. And pi, what this symbol is something called a constant, which means that it doesn't change at all. If I say pi, it's always going to be equal to 3.14 or something. So that's the value of pi. It doesn't have any units or anything, it's just a number. But how can I get this formula? Well, if I went over to my diagram here, and I split this circle up into tiny little pieces, kind of like triangular pieces, and I can do that all the way around, and then I can actually fit them together, sort of like this, and it will form a rectangle. And the length will actually be equal to the radius of the circle, and the width will be half of the circumference. And I'll go ahead and tell you that the circumference of a circle is 2 pi r. I'm not going to tell you where we get that from, we're just focusing on area. So if we know that the area of a rectangle is length times width, we can say the area of this circle, because we took the contents and we put it together in a rectangle, is going to equal r times 1/2 times 2 pi r is just pi r. It's going to equal pi r squared. So that's how we find the area of a circle. So in this case, it would be pi times 5 squared, 5 centimeters squared. And like I said, pi doesn't have units, so it's just going to be 25 pi centimeters squared. Just like we've always said, area, our units are squared. And finally, we're going to talk about spheres. So I'll give you a sphere here. And I want to know the volume of this sphere. And let's say the radius is, we'll say it's 5 centimeters again. So I want to know the volume. So I'll go ahead and tell you. So I'll draw a cone right here. This is a cone. If the height of the cone, so from here to here, is equal to the diameter of the sphere. So diameter for a sphere is kind of like height. So it's like 2 times the radius. So this would be the diameter. If that distance is equal to that distance, then 2 identical of these cones. So if we add these, that's going to be equal to the volume of the sphere. The volume of a cone, and if you multiply it by 2, that will equal the volume of the sphere. So to find the volume of the cone, well, we can just do our base times height formula. So we can say that equals, our base is a circle, so we said that would be pi r squared, and then we need to multiply it by the height. And since it's a cone, we divide by 3. I'm not going to go into why, but it's basically like if it comes to a point right here, that means you're dividing by 3. So that's how we find the volume of a cone. So we want to add 2 of those, and that will tell us the volume of our sphere. So we just said that the diameter was like 2 times the radius, right? So that's r plus r, which is 2 times r. And we just said that for this to be true, it has to be equal to the height of the cone. So we can replace 2r with h, and I'll go ahead and tell you when we do those calculations, you get 4/3 pi r cubed. And that's how you find the volume of a sphere. So thank you for watching.